Good afternoon, everyone. I am Pragya Srivastava. I am here to record a lecture on control system. The course code is KEC 602, and presently we are starting its Unit 3 in today's lecture. So, Unit 3 is time response analysis. So, we have studied transfer function analysis, steady space analysis. Steady state analysis and transfer function analysis were similar, but there were few differences as well when we consider initial conditions. Now, time response analysis, we will see the response of our system with respect to time. Now, we have to study the definition. Now, according to the definition, we also need to study how the time response can be studied when we talk about transient and steady state. So, response can be divided into two kinds. One is transient response and the other is steady state response. Then we have standard test signals. Test signals are nothing but the input signals. So, the input signals which we give to the system. So, the input signals can be many. So, for example, like we study this in signals and system, but here also we will go through all of them in a very brief and quick manner. So, there are like 1, 2, 3, 4 I have written already. Impulse signal, then unit step, then unit ramp, and then is parabolic. So, we have to study all of them, what these signals are. Of course, then we will consider a first order system, and to that first order system, we will give all the inputs one by one. Impulse, unit step, ramp and parabolic. So, the subject will be the first order system, and to that first order system, we will once give unit impulse, then we will give unit step, then we will give unit ramp, then we will get parabolic. So, this is how we will be advancing in this lecture. So, what is time response? What happens to the response when the time advances? So, let's say at t equals to 0, the output of the system is 0. Now, as and when the time advances, like 1 second, 2 seconds, 3 seconds, 4, 5, then we land out till 10 seconds. So, as and when the time advances, my system takes some time to settle. So, this is the time when the system is not settled yet. So, not settled means what is the settling point? What is the settling point? What is the steady state? Means the difference between initial and final magnitude should be minimum. So, from here and onwards, we consider starting from this window, the difference between initial and final is very low. How can I categorize? How can I say that? Let's say this is, the magnitude is 1 here. So, let's talk about this. This is 0.9. So, difference between 0.9 and 1 is just 0.01. Let's call about the same difference in between these two steps. So, here we are having 0.3 and here we are having 0.8. The difference between 0.8 and 0.3 is like 0.5. So, here it's like the difference between initial and final value is so much, and here the difference between initial and final value is just 0.1. So, we are calling it as steady state. I will remove everything on the slide. So, here and onwards, we call it steady state, and here we call it transient. Means we have transients there, we have variations there. So, the output overall is a sum of these two. So, one is transient, another is steady state. So, this is C transient and then C, steady state. The output of control system for a given input varies with respect to time. We can see when varies with respect to time, then it is called time response of the control system. The time response consists of two parts. First is transient response, CTR, or we call it CTR, transient. Another is steady state, C, steady state. The response of control system in time domain is shown in the given figure. Mathematically, we just add two of them. So this is CT is nothing but the symbolic representation for response, or we call it output as well. Here, after applying input to the control system, output takes certain time to reach steady state. So, having said that, this is the required time. This is the required time which involves to reach this state. This is the required time. So, this much time we require to reach this state. So, the output will be in transient state till it goes to the steady state. So, therefore, the response of the control system during transient state is called transient response. The transient response will be 0 for large values of t. Ideally, the value of t is infinity, and practically it is 5 times of the constant. Now, time constant. Mathematically, we can write the transient response as limit t tends to infinity, C transient will be equal to 0. So, when we talk about bigger time scale, then the transient will be equal to 0. Why? Because it requires a very small amount of time to settle from the given value to the steady state. So, when we talk about bigger picture, like when we take about time cycle of infinite, that response can be neglected, and therefore we are writing it as 0. Now, what is steady state response? The part of the time response that remains even after transient response has 0 value of large values of t is known as steady state. This means the transient response will be 0 even during the steady state. So, in this example, we have output Ct is equals to 10 plus E 5e raised to the power minus t. So, we can see very well limit t tends to infinity Ct, and we can see that we can realize that when 5 into exponential term, that is raised to the power minus infinity. So, of course, that term goes off. So, the transient component will be nothing but 0. Steady state signal. Now, standard signal, we have studied previously that we have to study 4 standard signals. First is impulse, then unit step, then unit ramp, then parabolic. So, this is a pictorial representation. We all know it is impulse, and unit impulse signal del t is defined as del t will be equal to 0 for t which is not equal to 0. So, for remaining values of t, like from here to here, everywhere, the magnitude will be 0 everywhere. So, del t will be 0 for all the non-zero values of t. So, at del t equals to 0, we have the definition of unit impulse signal. So, unit impulse signal is only defined at t equals to 0. So, unit impulse signal exists only at a value of t which is equal to 0. The area of this signal under the small interval of time around t is equal to 0 is equal to 1. The value of unit impulse signal is 0 for all other values of t. Now, what is step signal? We are very familiar with this mathematical representation of unit step signal. So unit step signal means the magnitude will be a 1, of course, and it is defined for all the values of t greater than 0. So ut is equals to 1 for t greater than or equal to 0, and then ut will be equal to 0 for all the values of t which is less than 0. So we have to see everywhere it is 0, and as and when we hit t equals to 0, it becomes 1. So it unit impulse, so it is 1. Let's make it 2 ut. So this output will be somewhere here, and here this magnitude will be 2 here. So unit step signal exists for all positive values of t including 0. All its values is 1 during the interval. The value of the unit step signal is 0 for all the negative values of t. Standard test signal part 3. Here we have to study what is unit ramp signal. So of course, unit ramp signal is a signal represented by this curve. Here we have RT equals to t for t greater than 0 or equal to 0, and for all the negative values of t we have RT equals to 0. So let's say for t equals to 1, for t equals to 1, this is the output and this is time. So for t equals to 1, the output is 1. Why? T equals to 0, the output is, t equals to 1, the output is nothing but t. So t is 1. So t1, this is the first node. T equals to 2, output is 2. This is the second point. T equals to 3, output is 3. Third point. T equals to n, output is n. So if you combine all these, you will get this output. So RT is equals to t for all the values of t greater than 0. Next, we have another representation. We can write unit ramp RT in terms of unit step signal. Of course, we can write it. So this is TUT, as simple as that. So a unit ramp signal exists for all the positive values of t including 0, and its value increases linearly with respect to t during the interval. The value of unit ramp signal is 0 for all the negative values of t. Here, unit parabolic signal. A unit parabolic signal PT is defined as PT equals to t square by t. Let's consider that it is generally proportional to second order. So it is t square. So we are generally taking it t square by 2 so that it successfully, and we can say that it is considerably map into its time domain and S domain conversion. So we take it t square by 2. So here for all the values of t greater than 0 including 0 as well, and for t having negative values it will be 0. We can rewrite unit parabolic signal in terms of unit step signal, and of course just like we have done in the case of ramp, we can write it as PT is equals to t square by 2 ut. The following figure shows the unit parabolic signal, and here PT equals to this curve here. If we plot certain values, let's say for t is equals to 2. So for t equals to 2, it will be t square is 4 by 2, and that is 2. The output will be of course 2. So for t equals to 3, it will be 9 by 2, that is for t equals to 4, it will be 16 by 2, that is 8, and for t equals to 5, it will be 25 by 2, that is 12.5. So if you join all these, it will be for 2, for 4.5, for 8, for 12.5, we will be having a curve like this. So this is extrapolating and finding out the resultant curve. So unit parabolic signal exists for all the positive values of t including 0, and its value increases non-linearly. Why we are calling non-linearly? Because in case of ramp, the value was increasing linearly. So here it's like this. It is not linear. The value of the unit parabolic signal is 0 for all the negative values of t. Of course, it is evident from the curve here. Now, let us consider a first order system. How can I designate this system as a first order system? We will study this as well. So, presently in this system, response to the first order system. As of now, I am telling you that this is a first order system, and we can somehow relate also. But why this is a first order system, we have to keep this question in mind, and we will realize it once we come on to characteristic equation. What is characteristic equation? How we can determine the first order or order of the system from the characteristic equation? That is yet to be studied. So in this chapter, let us consider the start and the basic and the foremost and the simplest system is first order system. Let us discuss the time response of the first order system considering the following block diagram of the closed loop control system. Here an open loop transfer function that having the transfer function st is connected with the unity negative feedback. What is happening is, let's say this is the open loop system. Let's say this is the open loop system, and then suddenly I connect it with a negative feedback system. So negative feedback, I am putting a minus sign here, and so negative feedback is fine. Then I am calling it unity. It means this is 1. So this system has been represented like this. So I was having a simple system which is having just an integrator, and then I have connected it in a pattern of negative feedback, and the gain of that negative feedback element is unity. So let us start with this. Of course, I know that the overall transfer function of a negative feedback system is Gs upon 1 plus Gs Hs. So here in the present question, this term is Gs and Hs is nothing but 1. So can I write it as Gs upon 1 plus Gs into Hs. Hs is 1 here. So I can rewrite it as 1 upon St plus 1. So this is the overall transfer function. So I can write in terms of output. Output will be equal to, we multiply Rs here. Okay. Output will be equal to, we multiply Rs here. So this is output this is the transfer function, and then I have to write the given expression in terms of output. So for that I will put Rs this side. So this is the output, not the transfer function, output of the first order control system. So we will be putting and we will be giving all the sort of 4 inputs. First will be unit step, second will be ramp, third will be parabolic, and of course we have to add one more. Let's call it A and B, that is impulse. So we will give all the 4 kinds of input to this system. So we will be studying more on this response of first order system in my next lecture. Thank you.